As with many programming languages, Solidity uses both dynamic size array and fixed size arrays. First, let's see how we declare a dynamic array of integers. We first write the data type. In this case, let's do an array of numbers. And the data type we're going to use is uint 256. Then we're going to make it public and we're going to call it dynamic array. Okay, now let's declare a fixed size array of integers and we're going to specify its size to 10. So we write uint 256. Then we specify its size between square brackets. We are going to make it public and let's call it fixed array. One thing to notice is that both arrays are declared as state variables, which means they are stored in the storage of the contract. This is important because Solidity has two types of array: storage arrays, as these ones that we just declared, and in-memory arrays. We will cover more about in-memory arrays later, but for now it is important to remember that storage arrays are stored in the storage. We will learn more about the storage layout for a storage array, but for now let's focus on dynamic arrays. Let's say we want to add elements to the dynamic array. How we can do it? Let's create a function called add element to dynamic array, and it's going to accept a uint and we are going to call it new element. And this function is going to be external. Okay? Then we simply say dynamic array dot push and then we add the new element. So what we are doing is adding to this dynamic array using the push function this new element that we are passing as argument. Okay, let's test it. We are going to deploy our contract and now we are going to simply call add element and we are going to add the value, let's say 9. Okay, the transaction was successful. You might have noticed that we have two functions here that are in fact automatically generated by Solidity, and this is because we are using the public keyword. So we can call dynamic array and fixed array functions, but they are getters. So if you see, they accept uint 256. This is the index. So if you remember, arrays start with index 0. So if we call dynamic array with the value 0, we should get the value that we inserted in the position 0. If we call with index 1, you are going to notice that the transaction is reverting because there is nothing there. Okay, so let's add a new element, let's say 12. The transaction is successful, and now let's call dynamic array again with the index 1 and we should get 12 because the second element added to the dynamic array is added to the next position, which is 1, and you see we get 12. Now let's extend the contract and we are going to include a function called remove last element of dynamic array, and this is also going to be external, And what we're gonna do is simply dynamic array dot pop. So the pop function is gonna delete the last element of the array. In this case, the first time we call this function is gonna delete the element that is stored in the index 1. In this case, the element with value 12. And if we do it again, it will delete the element of the index 0, which is 9. Okay, so let's test it. We deploy and then let's add again the element 9 and the element 12. Okay, let's verify that the values are there. We get 9 and we get 12. Okay, now if I call remove last element, it was successful, and then let's try to get the index 1. And as you see, we are getting an error because it was deleted. So let's try with the index 0. It is successful and we get the number 9. So let's remove it now. Remove, it was successful. If we try to get the value at index 0, it is going to be reverted. One thing to keep in mind is that contrary to other languages where the pop function returns the value that was in the last element of the array when it was pop, in Solidity that's not the case. For instance, if we want to get that value, let's say last element deleted equals dynamic array.pop, we are gonna get an error. Why? Because dynamic array, as is saying, the right hand side returns 0, so it doesn't return anything. So that's a small difference with Solidity.